and Math 1324, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing today. Now, without further ado, here's Mr. Isasi.
Hello everyone, my name is Mr. Isasi, and I'll be going over factoring today. Today's workshop covers factoring, and we have time composite and inverse functions. Okay, to start off, let me share my screen with you guys so you guys can because I'm going to do a PowerPoint with animation. So let me share my screen real quick. Okay, let me start from the beginning. Okay, welcome to Friday Math Happy Hour. This topic that I'm going to cover is called factoring. Okay, why is factoring important? Factoring leads to many math courses. For example, the NCBM class 0114 and 0314, which goes to pre-Cal 1, and then the NCBN 0124 and 0324 goes to 1324. And also 0305, all these, the elemental classes has factoring. Chapter 6 for 0305, factors in all forms, which I'm going to cover. I'm going to cover mostly 4 sections from chapter 6 for 0305. The majors that cover factoring is business and accounting, which is 1324, the business math, and 1325, the analysis business. And the majors that cover also factoring, math, computer science, and engineering. These courses most students have to take to comply with the requirements for students going for math, computer science, or engineering, which is pre-Cal 1, pre-Cal 2, Cal 1, Cal 2, linear algebra, and differential equations. All these courses have factoring. Okay, the purpose of factoring. The purpose of factoring quadratic expressions is to eventually lead to a method of solving a quadratic equation. Because a quadratic equation has the maximum power is going to be a 2. And these, right, where the graph crosses the intercepts, they're called the x-intercepts, or they can be called solutions, or zeros, or roots. They all mean the same thing. You see, these is what we're talking about. And also back here on the graph to the right. These are my x-intercepts. Okay, now, these are all real life examples of quadratic equations, or parabolas, right? They all have like an arc. You see, all these have like an arc, right? This is like a polynomial with many quadratic equations, because something like this is something like a power like say to 6, 8, or something like that, because they're all quadratic. But we're gonna this workshop is mostly for quadratic equations, which is something with x squared. For example, this one here, I believe is used like in the business math. And also this can be used in 0305 or also for 1314, right? Where the ball is kicked. This here are my x-intercepts or my solutions. And same thing with the example here on the left corner, on the right corner. Okay, now. Hey students, when I teach factoring, I always give the students these two handouts. These are the step 2 factors that I come up with. Okay, these are in the book, but at times they're explained a little bit different. I use these 2 handouts because at times there's a whole bunch of non-traditional students that haven't been in school for a long time, and those are the students that actually need the step 2 factor and the factor sheet. And right now, later on in this workshop, I'm going to show you how I use these. Okay, now this are the factoring steps, which was a handout. On the slide, on the previous slide. The handout to the left. Okay, the first step is the GCF, greatest common factor. What is the highest factor to factor out? And then the second step is determine the number of terms. No, make sure the terms are in order. If not, rewrite in order from highest degree to smallest degree before continuing. And then if it has 2 terms, it's either going to be a perfect square or a perfect cube. If it has three terms, it's going to be the x squared plus bx plus c. But I call it the easy factor because this is much easier than the number 2 here. Number 2 here, this is the ax squared plus bx plus c. There's two ways to to factor this type of expression. The first one is called trial and error, which is, I believe, is 6.3 in the Math 0305. But I like to use grouping instead because it seems easier for the students. Okay, and this is the one that I'm going to show you during this PowerPoint. And then finally, if you have 4 terms, it's going to be done by grouping. Okay, now this is a vocabulary for this, for the factoring workshop. What's a quadratic expression? It's an expression involving a square term. Examples: x squared minus x minus 12, or x squared minus 4, or negative 3x squared minus 4x minus 2. These are expressions because they don't have an equal sign. The difference between an expression and an equation has an equal sign, an expression doesn't. Okay, now factors. Factors are numbers multiplied together to get another number. Example, what are the factors of 12? How can we get 12? We can do it by 1 times 12, 2 times 6, and 3 times 4. They all equal to 12. So these are the factors: 1, 2, 3, 4, 6, 12. They're all here in order. Example number 2, what are the factors of 20? 1 times 20, 2 times 10, and 4 times 5. All these factors will give me 20. So what are the factors of 20? It's going to be 1, 2, 4, 5, 10, and 20. There they are. Okay, now what's the greatest common factor? This is like step number 1 from the handout that I provide to my students or to students, which is greatest common factor. The GCF of a set of numbers is the largest factor that all numbers share. Okay. Example 3. What is the GCF of 12 and 20, right? We already have it here, the 12 and the 20. So it means, what are the factors that they have in common? Right, it's going to be the 1s, the 2s, and the 4s. So the highest or the largest factor they have in common is going to be 4. So 4 is my GCF between the numbers 12 and 20. Okay? Okay, now let me show you how the factor sheet works. And most of the times, I tell students, if you can avoid the factor sheet, it's better for you. But at times, like I said earlier, a lot of students, they come back to school after being out of school for a long time. So those students I feel are like a disadvantage. Why? Because they've been out of school for a long time. So this handout will be very useful. So now let me show you how this is. How this works. Okay, this is a previous example from before, right? The factors of 12 and the factors of 20, right? The GCF was 4, correct? From the previous slide. Now, this is how I tell my students that don't know what factors are, how to use this handout here. Okay? How does the factor sheet work? So first, it was the factors of 12, right? Factors of 12, right? We go here on the factor sheet, right? Which is 12. So these are the factors of 12. 1, 2, 3, 4, and 6. Weren't they the ones from earlier? 1, 2, 3, 4, 6, and 12. And then we get the factors of 20, right? So the factor of 20 will be these here. So now, what's the greatest factor in common, right? So you take a look at all the factors in common, right? They have a 1, they have a 2, they have a 4. So the 4 is my GCF. That's how I tell the students to use this handout if they don't know how to do it the other way. Okay, but from now on, guys, I'm going to do it the way it should be done without any handout. Okay, this handout is to assist students, and I do not allow students to use this on the exam. They have to know how to get the factors. Okay, but this is used like for the homework or also in class, but not for exams. So these are the factoring steps, right? So number 1 was the GCF. What is the highest factor to factor out? That's step 1. Okay, so let's do step 1 here. So what is the GCF of 20 and 30? So we need to find the factors of 20 and 30. So first we start with 20. How can we get 20? 1 times 20, 2 times 10, 4 times 5. So these are the factors of 20. 1, 2, 4, 5, 10, and 12. Now we do 30. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So these are the factors of 30. So these are the factors that they have in common, right? So what's the greatest one? The GCF is 10. Okay. Now, what is the GCF of the variables x squared and x cubed? X squared is the same thing as x times x. And x cubed is the same thing as x times x times x. So then what's the GCF? How many do they have in common? They have in common 1, right? They have in common 2. So the GCF will be x squared. Okay, now observation. If both terms have the same variable, which means the same letter, the variable with the smallest degree is a GCF, which means the variable with the smallest power will be the GCF. That's like an observation. Okay, now this is doing step 1. You're going to factor out the GCF of 30x squared plus 20x cubed, right? So we already know what the GCF of, let's see here, of 30 and 20 is, right? It was 10. The GCF of the numbers is 10, and for the variables was x squared. So that is my GCF. Now I'm going to factor it out from this expression here, from 30x squared plus 20x cubed. So if I factor out 10x squared, what's left? Okay, so you can do it two ways. You can do it by dividing or by multiplying. I like to use multiplication. Like for example, I'm going to say one number times 10 will give me 30. So it's going to be 3. And you can always check your work as you go along, because 10x squared times 3 will give me 30x squared. Now the sign comes down. Now one number times 10 will give me 20. So it's going to be 2, right? But here, guys, we have x squared. We need x cubed. So we need one more x. So it's going to be 3 plus 2x is left. Okay? Now factor out the GCF continuum. Now here, example, okay, this is another example. This at times gives students a little bit of a problem here. But the numbers, the two numbers in parentheses, the two terms, is called a binomial, right? So this has a binomial of 2x minus 5, and also on the right side, 2x minus 5. So this binomial cannot be separated. At times, when the students do not understand about a binomial, I just say the numbers in parentheses or the terms in parentheses is like a family. A family cannot be separated. I always try to go down to a student's level. If the math vocabulary and the concept, if they're not understanding it, I try to use different ways for the student to comprehend. So by using the word family at times, it makes sense. Okay, for some students. So here, the GCF, right, is going to be 2x minus 5. The binomial 2x minus 5. So right, so they have the 2x minus 5 in common. So if I factor it out, right, I factor it out, what's left? It's going to be x plus 2. So to factor out or to simplify the expression, x times 2x minus 5 plus parentheses plus 2x minus 5 plus parentheses, this is the way it should be simplified. Okay. Hey, students, as I go along, if you have any questions, just put it in the chat. And this way I can answer your questions as I go along. Okay? Do not hesitate to put your questions in the chat. Okay, now, this example is crucial for factoring polynomials with 4 terms. The next example. This is how they show you in the book. Okay? They're going to factor by grouping, because you're going to group these two. When you have 4 terms, you're going to group the first 2 terms, and then you're going to group the last 2 terms. So this is group 1, right? So with group 1, which is 2x squared plus 8x, group 1, right, the factors of 2 will just be 1 and 2. And the factors of 8 are going to be 1, 2, 4, and 8. So the GCF between 2 and 8 is 2. Now for the variables, right? X squared and x. Remember what I mentioned earlier? If they both have an x, right? These two here is going to be the one with the smallest power, which is x. So between x and x squared, the GCF is x. So the GCF of 2x squared plus 8x is going to be 2x. Okay, so here I'm going to factor out the 2x right from the first two terms, from group 1. If I factor out the 2x here, right, I'll be left with x plus 4. Because 2x times x will give me 2x squared, and 2x plus 4 will give me 8x. Okay, now I'm going to do on the right side group 2. The sign comes down. Now comes group 2. And now repeat the same process. The factors of 3 will just be 1 and 3. The factors of 12 will give us 1, 2, 3, 4, 6, and 12. So they have the 1s in common, and they have a 3 in common. So 3 is the largest factor that they have in common. So the GCF between 3 and 12 is going to be 3. Now, here, guys, they don't have, right, both of these, the last two terms, they don't have an x. This one has an x, but not the 12. So they don't have no variables in common. So the GCF of 3x plus 4 is going to be 3. Right? So what's left? X plus 4. Now, what do they have in common? The x plus 4, right? So what's left? 2x plus 3. This is the way the book explains it. Okay, I have a modified version that I'm going to show you. Okay, I believe it's a little bit easier for students that haven't been in school for a while. So the answer will be, simplified, will be x plus 4 and 2x plus 3. Okay, now here, guys, we're doing 2c here, right? So determine the number of terms. So it was 4, so we're doing 2c. Why do I skip these two? 2a and 2b, because in 0305 they first start with GCF, which is 6.1, and then the second part of 6.1 is factoring with 4 terms. That's why I'm going the order of the book. Okay, now, so factoring by grouping continues. This is the method that I modified. Okay, 4 terms, factor by grouping. So this is the way I teach it to my students. Okay, factor by grouping. So I'm going to factor the first 2 terms. What does the 2x squared and 5x have in common? Right? 2x squared minus 5x. So the GCF is x, because they don't have no numbers in common. Maybe they do a 1, but the 1 doesn't count, because if I multiply 1 times 2 and 1 times 5, it'll give us the same result. So the 1 doesn't count. So it's going to be x. So for the first 2 terms, I'm going to factor out the x. So what's left? 2x minus 5. Why? Because x times 2x will give us 2x squared. And x times negative 5 will give us negative 5x. Okay, now here's my modified version. What I factor out here on the first 2 terms, I automatically put it on the right. And if it can be factored by grouping, it's going to work. And if it doesn't work, it means it cannot be factored by grouping. Okay, so this is my modified version. So what I do now, the sign comes down. Now I'm going to ask myself, what number times 2 will give me 4? So the answer is 2. Right? And we can always check our work. 2 times 2x will give us 4x. And 2 times negative 5 will give us negative 10. Okay, now the GCF is going to be 2x minus 5. So if I factor out the 2x minus 5, what's left? X plus 2. Okay? And again, this is modified a little from the textbook. The binomial that is left, okay, which means the binomial that's left after factoring the GCF, which means this binomial here. The binomial that's left, you automatically put it on the right. Okay, that's what I'm saying here. The binomial that is left after factoring the GCF on the first 2 terms will always be the same binomial left on the right side if it can be factored by grouping. So again, if it can be factored by grouping, you can always apply this simplified version here. Okay. Okay, now, so again, I'm done with 2c. So what's next? 2 terms. So 2 terms is either perfect squares or perfect cubes. So I'm going to do the perfect squares first. If you have perfect squares, x squared minus y squared is equal to x minus y and x plus y. And if it's a plus, it's going to be prime. It cannot be factored. Okay, now I always, when I teach this course, I always tell students to bring this handout to class. And then every time that we're going to factor, I tell my students, take out the factor steps, take it out. And then I keep repeating the steps. What's step number 1? GCF. What's step number 2? Determine the number of terms and so forth. And then I ask him, does it have 2 terms, 3 terms, or 4 terms? And then so that way they can see this is like like a map. And once all these are fulfilled, then you stop factoring. That means that you're done. Because at times students will tell me, hey, Mr. Isasi, I don't know when to stop. So that's why that was the purpose of this handout, so they can know when to stop, when you cannot go any further. Okay? So let's continue with 2a here, with two perfect squares. Okay, now, so I'm repeating the from the handout, right? So it's prime. If it's plus, it's prime. So here we go. These are perfect squares. For example, x to the fourth is a perfect square. Why? Because x squared times x squared will give me x to the fourth. Perfect squares means what two numbers multiplied by themselves will give me an equation on the left. So for example, x times x will give me x squared. So x squared is a perfect square. 1's a perfect square because 1 times 1 will give me 1 squared. 4 is a perfect square because 2 times 2 will give me 4, right, and so forth. So the more of these that you know, the better you'll be off. Okay, so here I stop because then 36 is next, and then 49, and so forth. You should know at least all the way to 100, or maybe all the way to 144, which is 12 times 12. Okay, now, so how does this work? For example, x squared minus 1, by following the rule here, will be x minus 1 and x plus 1. Because if you happen to do the FOIL, right, the two terms in the middle will cancel. So x squared minus 1 is going to be x minus 1 or x plus 1. X squared minus 4 is equal to x minus 2 and x plus 2. X squared minus 9 will give us x minus 3 and x plus 3. Okay, now, please write in the chat, what do you think x squared minus 49 will be? Someone, please. Very good, Jacob. X minus 7 and x plus 7. How about this one here? X squared minus 81. What do you guys think? Very good. Mr. Smith, x plus 9. Hey guys, here I put the plus on purpose because it doesn't matter, guys, what goes first, the plus or the minus, as long as they're different signs. You see, same thing here. As long as they're different signs, you can put it x plus 9 or x minus 9 or vice versa. How about x squared minus 100, right? It's going to be 10 times 10, right? So it's going to be x minus 10 and x plus 10. How about this one here? Someone, this is a little bit more challenging. Can somebody tell me what the binomials is going to be? I'll give you a hint. Is the 25 a perfect square? Yeah, it's going to be 5. Is the x squared a perfect square? Yes, it's going to be x. Same thing with the 36, right? So it's going to be 5x minus 6y and 5x plus 6y because both of these terms are perfect squares. The 25 in the x squared is a perfect square, and also the 36y squared is a perfect square. Yeah. How about x squared plus 36? Someone, please. Okay, hint. Remember, guys, if it's a plus, it's going to be prime. If it's plus, it's going to be prime, right? So always observe the sign between the two terms. If it's minus, you can actually do it, right? You can simplify, but if it's plus, the answer is prime. Please don't forget that. That's a common mistake that many students make. Okay, I mean, that's why I did that on purpose, right? I put the plus there. I put x squared plus 36. So you know that it has to be prime. It cannot be factored. Okay? Okay, now how about x to the fourth minus 16? So x to the fourth, right, is a perfect square. It's going to be x times x. And the 6 is a perfect square, right? It's going to be 4 times 4. And it's a minus, so we can do that, right? So it's going to be x squared minus 4 and x squared plus 4. Remember, the x squared plus 4 is prime, so this cannot be factored no further. The x squared minus 4 is going to be x minus 2 and x plus 2. Right? And then the x squared plus 4, we just break it down. This is crucial, guys, for pre-cal 1, because you're going to be finding the zeros and the polynomial at times is to the 4th degree or 6th degree. So this is crucial for 1314. Okay, now let's do perfect cubes. Okay, so perfect cubes, guys, these are the rules for the perfect cubes. Okay, this is called the difference of two perfect cubes, and this is called the sum of two perfect cubes. So this is how it works. So these are perfect cubes. For example, x to the 6 is a perfect cube because x squared times x squared times x squared will give me x to the 6. Same thing with x cubed is the same thing as x times x times x. So same thing is 1 is a perfect cube. Why? Because 1 times 1 times 1 will give me 1. Same thing with 8 is a perfect cube because 2 cubed is equal to 8. So it's wise, guys, to know the perfect cubes, which are 1, 8, 27, 64, 125, and so forth. If you guys want to get more, right, so just multiply 6 times 6 times 6, and that'll be what goes here, and do the same thing with 7 and 8 and so forth. Again, the more of these that you know, the better you'll be off. But these are the most common ones. Okay, now, this is how it works. So is it 1 or 2? Is it 1 the difference or 2 sum, right? So this is going to be the sum, so it's going to be like number 2. So you bring down the formula down here, okay? So then we have to rewrite x cubed plus 125 as perfect cubes, if they are perfect cubes, right? So we know that 125 is equal to 5 cubed. So this simplifies to x cubed plus 5 cubed. So I know this is a formula that I'm going to be using, right? So we're going to let x equals to x. We're going to let y equals to 5. So everywhere you see an x, you're going to put x. Everywhere you see a y, you're going to put a 5, right? So what's my x? Will just be x. What's my y? It's going to be 5. What's x squared? What's x times x? Will just be x squared. What's x times y? What's x times 5? Will give us 5x. What's y squared, right? If y is 5, what's 5 squared? 5 squared, right? Then we simplify it. So x cubed plus 125 is the same thing as x plus 5, x squared minus 5x plus 25. This is crucial, guys, also for 1314, and also I see it a lot in Calculus 1, okay? And also in 1325. Let's do one more of these. Now let's do, right, the perfect, the difference of two perfect cubes. So this is a formula I'm going to use, formula number 1 here. So 27, right? So we have to rewrite it because 27 is the same thing as 3 cubed. So 3x will be, let x represent 3x, and let y represent 4y. So everywhere in the formula we see an x, we're going to put 3x, and everywhere we see a y, we're going to put 4y. Right? And same as before, my x is 3x, my y is 4y, my 3x squared is going to give us, right? No, let's do it like this, and then on the next, here at the bottom, we'll simplify it. We'll just put the value for x and the value for y. So x is 3x, right? What's 3 times 4? Right, we're going to put 3x and then the 4y. And right now we evaluate it. And here we're going to put 4y. Now, if we evaluate it, it's going to give us 3x minus 4. 3x squared is the same thing as 3x times 3x, which will give us 9x squared. And 3 times 4 is 12, and x times y is xy. And 4y squared is the same thing as 16y squared. So we're done with perfect cubes, right? Now comes the 3 terms. So it's going to be number 1, the easy factoring. Okay, this is not called easy factoring in the book. They just call it factoring in the form of x squared plus bx plus c. But I call it the easy factoring because it's much easier than number 2 here, guys. Okay. So if it can be factored, this trinomial becomes the set of 2 binomials. Okay. Okay. Now, here's how it's done. These are the rules here, guys. This is called my bx term. This is called my constant term. So if the constant term, which is c, if it's positive, the signs will be the same. What signs? The signs here on the binomial. If the constant term c is negative, the sign is different. Okay, so here we go. So are the signs the same or different for the following examples? Every time that, again, when I teach this section here, I always give the students like a pop quiz. I even tell them, hey guys, you can have a quiz for extra credit. And I tell them, you don't have to solve for it or you don't have to simplify it. All you have to do is tell me what the signs are. Okay? So example number 1. Can somebody tell me what the signs are going to be? Right? Before you answer, read here the conditions. If my constant term C is positive, the signs are going to be the same. Very good, Mr. Renteria. How about this one here? The signs, what are they going to be? Different. Very good. How about number 3? Same or different? Very good, guys. Different. How about number 4? The same. Very good, guys. Excellent. Hey, guys, but you know why I do this? Like a quiz, because every time that you tell students there's going to be a quiz, if it's for a grade, right? They get all paranoid. But if it's for extra credit, especially those students that haven't been in school for a long time, I try to nurture them so they can understand what to look for. And this, when you factor in this form, the sign of the constant term is one of the key points to start off. Because I tell my students, the signs is half the battle. Once you get the signs correct, then you're halfway there. Okay, now let's actually simplify it. Okay, so this was the example on number 1, same signs. So what I do, guys, I always bring the sign down. So if they're going to be the same, right? So they're both going to be negative. Okay, so x squared minus 10x, I know that the first 2 terms are going to be x and x. Why? Because x times x will give you x squared. Now what's next? What's next are the factors of 24. And I already showed you how to get the factors. If you guys are confused, right, with the factors, you can use a factor sheet. So I try to go in order this way. If you guys know the answer without even getting the factors, it's more power to you. But like I said earlier, I always try to lift the students that are real behind, that they don't understand. So this way, I do it all the way out. So I begin 1 times 24, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So these are the factors of 24. Now, what's here, guys, is what we do here. We have to add them. We have to add the factors. The sum of the 2 factors must equal to the bx term. So, and this idea, guys, I got it from a student, because every time that I actually teach, I tell my students, if they have an easier way to explain it to me or to the class, the class will vote. And if they say it's easier than my way, then I use your way. So this, I got it from a student. The student was always confused. She would say, Mr. Isasi, so what do I do here? When you have when the sign's here, what do I do? And then after I showed her, after that, she mentioned, hey, Mr. Isasi, you know what I do? The sign of the constant term, I always put it here because this is what I have to do with the factors. And then we put it to the test. We asked the class, and the class agreed. So my method, guys, is always getting like I said, like perfected or modified every semester by the input of the students. So this I got from the students, guys. This part here. So that way they know what to do, right? So my object is to get -10, right? But I tell my students, don't worry about the -10. Just get the sum of the factors. 25. 14, 11, and 10, right? So the 10 has to be here. If the 10 is not here on the bx term, then this trinomial cannot be factored, right? But since the 10 is here, right, 6 and 4 is my match. So I'm going to put -6 and -4, right, which is -10. So I'm going to put -6 and -4. I always tell my students, let me go back here. I always tell my students to always put the bigger factor first. Okay? It doesn't matter when the signs are the same, but it does matter when the signs are different. So at the beginning, I don't give my students a choice. I just say, always put the bigger sign first, and right now I'm going to show you why. Okay? On the next slide. So again here, right, we knew it was different signs. So, right, different signs. So this one comes down. So it's going to be minus and plus because if the signs are different, and this one is minus, so that one has to be plus. Okay? So it's going to be x minus and x plus. So my next step, we get the factors of 30. Right? 1 times 30, 2 times 15, 3 times 10, 5 times 6. So now we have to subtract the factors to give me 7 or negative 7, right? So this means the difference of two factors must equal to the bx term. So we have to get negative 7. So 30 minus 1 is 29. 15 minus 2 is going to be 30. 10 minus 3 is going to be 7. And 6 minus 5 is going to be 1. Okay, this method, guys, is simplified from the textbook because at times the textbook would say something like this, guys. How can I get 30, negative 30? Negative 1 times 30. 1 times negative 30. And to me, that's too long for the students because I used to do it that way and the students would get all confused. So that's why I began modifying the way to factor. Okay? So 10 and 3 is my match, right? Because this will give me 7. So it has to be negative 10 plus 3, right? Because this will give me the negative 7. Because remember, it's a difference. So it's going to be x minus 10 and x plus 3. Okay, now here's an observation, guys. Okay, it says the sign of the bx term, this sign determines the biggest factor or the largest factor. But if the sign of the bx term is brought down, then the largest factor always goes first. And also, I got this idea from another student. This student mentioned, Mr. Isasi, you know what I do? I always bring the sign down. I said, why? Because you mentioned in class that the sign of the bx term determines the biggest factor. So if I bring the sign down, right, the biggest factor always goes first. And it made sense. And the class agreed, right, that it was easier than my way, so I adjusted to the student's way. And I also gave extra credit because I told him if you have a way to explain it that's better than my way for the students, right? Because it always takes a student to help another student so they can better understand it. Because at times, the instructor cannot go to the student's level, okay? And that's why at times a student learns better from another student. But the student that's actually teaching the other student, they have to know what they're doing, or else they're gonna. It's like leading the blind man leading the blind. So it's not gonna work. So now I'm gonna use that simplified method, okay? So here the signs, right? So it's gonna be different signs and the difference of the factors. So the sign comes down. So it's gonna be x plus and x minus. Factors of 20. How can we get 20? These are the factors of 20. Now, right, so it's going to be the difference. 19, 8, and 1. Which is a 1, right? So it's going to be the 4 and the 5, right? Remember, guys, if you bring the sign down, the biggest factor always goes. Let's do example number 4 now. So it's going to be the sum, the same signs means the sum of the factors. The sign comes down, so they're both going to be positive. So now the factors of 15 are going to be 1 times 15 and 3 times 5, right? And it's going to be the sum of the factors, which is 16, and it's going to be 8, right? So my bx term is 8, so it's going to be 5 and 3. Hey, it's not wrong if you put 3 and 5, but at times I don't want to give the students the option, because if the student is barely learning or is one of those students that hasn't been in school in a long time, if I tell them it matters on a certain extent, right, they're going to get it confused. So this way, they can learn it on their own. But if they follow this method, they cannot go wrong. Okay, now we're done to factoring, right? This is the last part of the presentation here. So factoring in this form. This is a little bit more challenging. Okay, this form, you have to multiply the A and the C, right? A times C. So it's going to be 30. Factors of 30. How can we get 30, guys? And this is crucial here. The 3 terms, 4 terms, 2 terms, and factor. We start with 3 terms. Then my next step here, you have to have 4 terms. Okay, this is like a guide here. So 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So here, guys, right, it's going to be the when we add them. So factors to get the bx term has to be 11. So this is 31. 17, 13, and 11. So this is my match here, guys. So before I convert it into 4 terms, right? So I put it here, guys, right? That's why I know that the positive 6x plus positive 5x will replace my 11x. You see, now this is something that we saw at the beginning, right? With 4 terms. So this is really, we already done this before. So what do the first 2 terms have in common? is going to be a 3x. What's left? X plus 2. Remember what you put here goes over here. The sign comes down. One number times x will give me 5x, so the answer is 5. And you can always check your work. If you distribute, 5 times x will give us 5x. 5 times 2 will give us 10. So then they have in common the x plus 2. What's left? 3x plus 5. It's factored. Okay, let me do one more example, guys. And then I'll be done with the factoring part. So again, right, this is a number here, right, is like an a. What's the difference between the a squared and the x squared? The a squared has a coefficient larger than 1. It means it can be a 2, 3, or something like that, but not a 1, because if it's 1, it's factoring the other method, the easy factoring. So we multiply 2 times 9 is 18. Factors of 18, right? So same procedure as before. We're going to subtract the factors. So when we subtract them, it has to give me negative 3x, right? So where's my match? This will be 17. This will be 7. This will be 3, right? So this is a match that I'm talking about, right? So now before I convert the negative 3x into two terms, it's wiser to do it here. This way you guarantee that you don't put the wrong signs on the terms. So negative 6x, right, plus 3x, that does give me negative 3x. So this will replace my negative 3x. Right? Now we go to 4 terms. Right? And these two are equivalent. Right? There's my 2x squared. Here's my 2x squared. There's my negative 9. And the negative 3x was replaced by negative 6x plus 3x, which I got it from here. Now again, repeat the process as before. Factor the first 2 terms, which is 2x. What's left? X minus 3. And again, you can always check your work. 2x times x will give us 2x squared. 2x times negative 3 will give us negative 6. So what you factor out also goes on the right side. The sign comes down. Then you ask yourself, what number times x will give me 3x? The answer is 3. And again, you can always check your work. 3 times x is 3x. And 3 times negative 3 will give us negative 9. So I know I'm on the right path. So what does these two terms have in common? Will be the x minus 3. So what's left? 2x plus 3. That's how you factor that one. Okay, now guys, we have like 13 minutes, so let me try to finish out real quick. Hey guys, these are the math courses, right? These are problems that I got from the textbooks. This is Math 1324, section 1.7, quadratic equations. Use factoring to solve each equation, right? So these are the ones that are from 1324, from the actual book, right? These, I already kind of covered them, right? This is the easy factoring, the factoring by grouping, and this is the perfect squares. These are something from 1325, right? 1325 or calculus 1 when you do limits. This is number 40 from 1325 from page 569. This is just to show the students who are actually, because there are students here that are from calculus 1 and from pre-cal, because I've seen them in class. So this is just to show you guys that all this is not that hard, right? The hard part is knowing or trying to remember how to factor. This is actually a problem, right? So these are two what's it called? 2 trinomials here, right? So you have to work those also by factoring. This is from 1314. Find the zeros, right? The zeros is the same thing as the x-intercepts or the roots or the solutions, right? These are all from 1314. So just to tell you guys, it's very important for you guys to know how to factor. Okay, now I think Ms. Chuka will take over the presentation. Let me stop sharing real quick.
Right, thank you, Mr. Isasi. So
Sorry that I took too long, Yvette. I apologize.
no. This is okay because our session today was on factoring. So these last few minutes is just to kind of cover from last week that we didn't get to finish. But
Okay.
the code for today is happy, and as Mr. Isasi was saying, factoring is a crucial topic or concept in all of our math courses. And so for 1314, factoring will be used quite a bit starting in chapter 2. And for 1324, you guys are already starting to see it with the quadratic functions, okay? So one of the topics that we had from last week was composite functions, and we didn't get to kind of finish it. And so a composite function, the first thing I wanted to show you here is when you see this circle, that is telling you that this is composite. It's not multiplication, but composite function. And so the way that we define it is whenever you see the symbol f composed with g, we can rewrite it as f of g of x with a g of x inside. The second equation in the problem is always going to be what goes inside. Okay, and so the first thing to do is substitute what g of x is. So g of x, they tell us, is x minus 3. So we would put it into the parentheses. And then remember that whatever is in the parentheses, you're going to substitute it in for the x of that function. So this right here, we're going to put it in for the function f. And we do that because it's identifying that it's for the function f. So we substitute that in, then we can evaluate it, and we get x minus 3. And so just recall that this whole x minus 3 is what took place of this x. And then we have a plus 4. So then you want to simplify, and we get x plus 1. So the composition of f and g here is x plus 1. Okay, so let's look at b. What if we reverse it? So now notice that the second function is f, so that's what's going to be in the parentheses. So we're going to have g of f of x. F of x is x plus 4, so we plug it in. And then anywhere you see x plus an x in the function g, we're going to replace it with x plus 4. And so here we would get x plus 4 minus 3, which is going to give us x plus 1. Now notice that they both gave us the same answer, and so that is just a coincidence. It doesn't always happen that you get the same answer there. Okay, so let me give you one more here. What if we have the same function, g composed of g? So we still follow the way it's defined. So this second function goes in the inside. So we have g of x. G of x is x minus 3, so we're going to plug it in for g of x. And we get g of x minus 3. So now we're going to take whatever's in the parentheses, and we're going to plug it in for x. So we're going to end up with x minus 3 minus 3, which is going to give us x minus 6. Okay, and so this should say g composed of g. Okay, let's do one more example. So here we have x squared, and then we have x minus 2. And so if we want to find f composed of g, then we're going to have f of g of x, substitute the x minus 2, and then we're going to take the x minus 2 and plug it in for x squared. And so this would become x minus 2 squared. So then depending on the software that you're using, if you're using MyMathLab, sometimes it's going to take this as your answer. But I know for sure in WebAssign, you want to go ahead and multiply this out. Okay, so we're going to end up with x times x, which is x squared. And then x times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is a positive 4. And then we simplify, combine our like terms. So we get x squared minus 4x plus 4. Okay, so g composed of f, what do you think we would get here? So we'll do the first one here. So if you plug in x squared for your x, what would be our answer? What do you guys think? Okay, so if we plug it in, we're going to end up with, here's my x, we're going to plug in x squared. So we end up with x squared minus 2. And then let's try the g composed of g. So if I plug in the g of x, then I get x minus 2, plug it in for my x here. And that's going to give me x minus 2 minus 2, which is x minus 4. Okay. And then just one last one. Letter C is what sometimes students struggle with. And so let me just go through this. We have about 8 minutes left. So we have f composed of g of is going to be equal to f of g of x. Plug in the g of x. So we get f of x squared. We're going to plug it in for x here. And we get the square root of x squared plus 4. Okay, so then let's do the letter b. If we reverse it, we're going to end up with g of the square root of x plus 4. Anywhere I see an x, I'm going to replace it with square root of x plus 4. And notice that my x is squared, so I'm going to have it squared here. The square root and the square become 1, leaving us with x plus 4. So then we're going to need to find the domain. So it says to find the domain of each function. So if you have f of x, square root of x plus 4, then we set the radicand greater than or equal to 0. So x is greater than or equal to -4. That means our domain is from -4 to infinity. And then for the function g, notice that for the function g, we don't have a square root, we don't have a fraction. So that means that our domain would be -infinity to +infinity. And then we're interested in finding the domain of the composition, okay? So whenever you're finding the domain of the composition, it's kind of a two-step situation. First, you have to consider the domain of the second function here. In this case, my second function is g. And so for the second function, our domain was -infinity to +infinity. And then we can consider the domain of the entire composition. So here my entire composition was square root of x squared plus 4. Well, since the x is squared, it doesn't matter what value you put in here. If you put in a negative value, it's always going to be positive. And so that's going to make our domain -infinity to +infinity, because we'll never end up with a negative in the square root. So if we look at the purple and the blue here, the first one and the second one here, they both have in common from -infinity to +infinity. And so therefore your domain will be from -infinity to +infinity. Okay, now look at the one for g of f. So since f is the second term, you look at the domain of f, and the domain of f is -4 to infinity. So we want to keep that in mind, which is right here in the blue one. Okay, now the domain of the whole composition was, since we have x plus 4, there's no fraction, there's no square roots, so this is going to be from -infinity to +infinity. So you want to ask yourself, what is the -infinity to +infinity and the -4 to infinity? What do they have in common? And what they have in common is from -4 to infinity. And so your answer for the domain of this composition is going to be what they have in common. In this case, -4 to +infinity. Okay, so that was basically what we missed from the last week's session. And so we just wanted to show you these few examples. Next week, I'm going to pass it over to our friends from our Student Success Tutoring Services. But next week, our session is going to be on, we're going to basically review topics for the exam 1. So it's going to be a review of these last 3 weeks that we've been in class. And so hopefully you can join us and come see us then. So if you do have questions, feel free to stay here and we can get you into a tutoring room with one of our tutors, and we'll take it from there. Have a good weekend.
Okay, thank you, Ms. Chuka. And guys, remember to sign in. I'm going to be stopping the recording now, but if you have any questions, feel free to type them up, or we can move you to a room with a tutor.